Well, good morning, everyone, and welcome to another exciting Exploring by the Seat of Your Pants broadcast. We've got a bunch of new faces in the crowd today, so if you are joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And I want to say a big thank you to all of you for joining us during our Epic Space Month. We have been joined by, I think, 5 now NASA engineers, explorers, roboticists, and beyond. We've got a few more to come to wrap up the month in early November as well, but it has been an absolutely wild ride featuring all sorts of stories of exploring the universe around us. You can check out all of those on our YouTube channel, and I really encourage you to. And jpl.nasa.gov is like one of the best educational resources of all time. So do check that out as well. Before I dive in with today's speaker, I want to note we do have a Kahoot together. So if you're joining us live on StreamYard, on YouTube, wherever you're tuning in from, you can tune in with this game pin in a separate tab and join us for a little quiz between the talk and Q&A. So please feel free to do that. We'll be doing that in about 20-25 minutes. But today, I'm so excited because we are joined by one of my all-time favorite scientists here at the program, Dr. Abby Fraeman. She is a NASA engineer who gets to work on sending robots to Mars. Her career journey is awesome. We're going to learn a little bit more about it, her missions that she's working on now, what the prospects for life on Mars are, and so much more. So you guys are in for such a treat. And without further ado, Abby, welcome back to the program, and thank you so much for joining us again.
Oh, thank you so much for having me. I'm thrilled to be here today.
I think this is like your 10th or 15th time. Like we would have Abby on every week if her schedule allowed, but unfortunately she's got to work and do all these things like, sending robots to Mars and stuff. So we can't have her regularly, but whenever she gets a break, we're like, yes. And then we get to have her on. So thank you again. This is great.
Oh, I just have so much fun.
Well, I know you've got a lot to share, so I'll zip it and leave you to dive in with your presentation. If you want to bring that up, I'll highlight a few of those cool resources again as you get that ready, and then we will dive in together. So a big welcome to our audience in Florida, Massachusetts, BC, Alberta, Ontario. Like you guys are everywhere today, which is so exciting. And Abby, it looks like we are pretty much good to go. Once you get that full screen, we are set.
All right, fantastic. And just confirming you're seeing the right side.
I am, but now there's a weird black screen beside it, which wasn't there before, but that's kind of interesting. Try it, and let's go to the next slide.
Okay.
And see what happens. Now we're perfect.
Is this better?
That's beautiful.
Okay, fantastic. Well, welcome, everybody. Thank you so much for inviting me. I am thrilled to be virtually joining you today to talk to you a little bit about my job, where I get to spend my days exploring Mars, which I think is pretty cool, and I love talking about it. Just to tell you a little bit about where I'm talking to you from, I work at NASA's Jet Propulsion Laboratory, which is one of several different centers that make up NASA, which are located all over the United States. When you think of NASA, you might think of things like the astronauts or rocket launches, and those are parts of NASA that are other areas of the country. So the astronauts are out of a place called Houston, Texas. The rocket launches happen in Orlando, Florida. Me, I work in Pasadena, California, at a place called the Jet Propulsion Laboratory. And our branch of NASA really specializes in robotic exploration of the solar system. So building robots that can go to places like Venus and Mars. And we just launched something to Europa, which is one of the moons of Jupiter. So ways to learn about our solar system and explore it using robots. My other office that I like to say is on Mars. So the planet that I spend my most time thinking about studying is Mars. It's known as the red planet. It's the 4th planet from the sun, so a little bit further out from Earth. It is Earth's next door planetary neighbor. Mars is pretty different than Earth, though. The surface is very, very cold. Its atmosphere is very, very thin, and the planet itself is about 1/3 the size of Earth, so a little bit smaller. I'm really interested in studying Mars because I think it has the potential to answer some really big questions, and perhaps the biggest of these questions is the question of, are we alone? This is something humans have wondered, I think, ever since they looked to the stars and wondered if there is life elsewhere in the universe. And Mars is a really interesting place to study this question because we think a really long time ago, when life was first forming on Earth, the conditions on Mars were actually pretty similar to the conditions on Earth. The planet was a lot warmer. Maybe there was some water. Maybe all of the ingredients that we know were required to start life on Earth were also present on Mars. And so wondering if that actually did happen and how it happened is going to help us understand a lot about whether we're alone. Right now, we don't know if there's life on Mars. We haven't found any evidence of life on Mars. But the question is, was there maybe once life on the past in Mars? I'm also excited about studying Mars because it's a place, and it's a place that I think humans could visit one day. We know the surface is rocky. It's somewhere humans could walk around and make measurements and do science to learn more about the way this planet works. But before we send humans to Mars, we need to understand the kind of conditions they'll face. What are some of the hazards they might encounter on Mars? What are these really cold temperatures like? What's the kind of radiation doses they might expect when they're exploring the Martian surface? And also, what are some resources that might be present on Mars that humans could use? Are there places that we could pull frozen water out of the crust or the minerals on Mars, places where we could essentially live off the land rather than having to bring lots of stuff with us from Earth? And we need to know the answer to these questions before I think we can successfully send humans there to explore. Now, to answer both of these questions, looking for past life and understanding the kind of conditions future human explorers might face, we basically do the science of geology, which on Earth is studying the rocks on Earth to learn how they formed, to learn what they're like. And my job is to do geology on Mars. As part of that, I've gotten to go to many Mars-like places on Earth. Places like Hawaii and Iceland that are made of rocks that are nearly identical in composition to the kind of rocks you get on Mars, which, if you actually stop and think about that, that's pretty wild. That here we have a whole other planet and it has rocks that are made of the exact same things as the rocks we have here on Earth. That's pretty cool. Other types of places I get to go are places where we have very arid environments, very dry environments. And here's some picture that I actually took this past summer when I went to Southeast Oregon in the United States, where it's a very desert-like environment and there are these beautiful lava flows, also similar to Martian rocks. On Mars, of course, we can't actually walk around with our geologist field hammers and hand lenses. So instead, we send our robotic proxies to explore the planet's surface and learn more about it and its environments and its rocks. And here's just a graphic showing some of the spacecraft that we've sent to Mars or attempted to send to Mars over the course of our history of exploration of the planet. You can see all of those robots that are around in this big circle around the planet. Those are satellites that we've sent to orbit Mars and observe its surface from way high above, looking down at the planet and making measurements. And then we've also had the great fortune to land a couple of spacecraft on the surface of Mars, including some landers that just land and stay put, or my absolute favorite, rovers that we can land but then drive around on the surface to explore the rocks. Our orbiters still send back some pretty incredible data. Here's a picture. This is Mars. This is the surface of Mars. This is taken from a camera that's on one of the orbiters right now that has incredibly high resolution. It can see really, really small features as small as 25 centimeters, which is pretty tiny. This is a view looking down onto the surface of these rocks that maybe you can see these beautiful layers in the rocks. These are rocks that are called sedimentary rocks. They were made through processes of wind or water. And by studying the layers in these rocks, we can learn about the environments that were present as the rocks were forming. Was Mars a wet planet, or was it a dry, windy place? You can see kind of throughout these rocks, you might think those look like water waves, maybe those kind of ripply things. It's not water, it's actually sand. That's Martian sand. Here's another picture of just a huge field of Martian sand. I think it's really beautiful. And here's a fun fact about Mars. The sand on Mars isn't white like a lot of the sand here on Earth. It's actually black. And that's because all of the sand on Mars is made up of broken bits of volcanic rocks. And so you get these beautiful fields and fields of black sand, which form these beautiful patterns that we can see from above of the very thin Martian atmosphere blowing them around and forming all of these ripples and really cool features. Here's another picture of Mars taken from orbit, and you might say, that's kind of a funny looking picture of Mars. Why is it green and pink and purple? I thought Mars was red. And you'd be right. So this is an example of another kind of data that we can get from orbit, which tells us not only about the way the planet looks, but about what it's made of. So this is actually a representation of the different kinds of minerals that are on the surface, and each color represents a different kind of mineral. So there's things like volcanic minerals in here, but there's also things like clays and salts and all kinds of minerals that form in watery environments. And this was one of our first clues that Mars, even though it's very, very cold and dry today, had a past that was a lot warmer, because we found these minerals that we know form with liquid water. So we know it must have been present in the past. This is actually a very special place on Mars. It's so special, we've landed a rover here, the Perseverance Mars rover, and it is exploring all of these different minerals and features to learn more about Mars's past. But of course, as I mentioned, to me, the most exciting way to explore Mars is to get down onto its surface and to virtually walk around and act like we would as a geologist here on Earth, but in these beautiful areas on Mars. This was kind of very similar to our first views of Mars. This is a view of, I would call this typical Mars, kind of volcanic terrain, broken up lava rocks everywhere. But what inspired me to really explore Mars was seeing all of this kind of change and seeing new views of Mars that happened in the early 2000s. This is a representation of a rover that got sent to Mars. We actually sent two. They were identical rovers named Spirit and Opportunity, that landed on the surface of Mars to explore the rocks. And they were the first rovers we had that had the ability to look for really definitive evidence that Mars once had liquid water, and it's passed this smoking gun to tell us if Mars was once a warmer and wetter place. When Spirit landed, it sent back photos that looked like this, our kind of typical Mars that we knew and loved. But when Opportunity landed, this was the picture we first saw. And this was just such a different way to see the surface of Mars. We see all of that kind of black Martian sand, but poking up in the distance, you can see those really astonishingly light colored rocks. And what it turns out is that these are something called bedrock, which to a geologist is really exciting, because bedrock is something that's formed in place. And it tells you a lot more about the context of how the rocks formed. And not only was this bedrock, but it was the kind of rock that we found forms in watery environments. And so it was our first real proof 20 years ago that Mars once had liquid water on its surface. Now, 20 years ago, I was about your age. I was in high school, and I had the opportunity to come out to the Jet Propulsion Laboratory and be in the room when this image first came down. And there I am, and my mind is just getting blown, seeing this view of Mars that we'd never seen before. And it really showed me that this was a place with so much diversity and things to explore. And I was so jealous of the scientists who got to have this for a job, exploring this planet and looking at rocks like this, and then understanding what it all meant in terms of what Mars was like 3 billion years ago. I thought that was so cool. So I went on to study planetary science, which is what you study if you want to learn about the geology and the history of other planets. And this is what set me on my path to become a research scientist here at JPL. And I won't talk much more about Spirit and Opportunity, but I will say, if you want to learn more about this wonderful mission, there's a documentary that's out on Amazon Prime that's called Goodnight Oppie, and it tells the whole story of this mission, how it was built and operated, and how it lasted way longer than scientists and engineers thought it would. And it tells a lot about the humans who built these rovers too. So I highly recommend it. But today I get to work on the next generation of rovers that followed up on Spirit and Opportunity. And that's a rover called Curiosity. So you can see, if I pull up my laser pointer here, here's a picture of Opportunity to scale down here. The rover I get to work on now is called Curiosity, which is way, way bigger than Opportunity. Here's a picture of Curiosity. It's a pretty great rover. It has a laser on its head that we use to shoot at rocks, and we can measure the composition of the rocks looking at the plasma we create when we vaporize them. It has a drill on the end of its arm that we can use to drill into rocks. And what Curiosity actually is really a mobile chemist. So if Spirit and Opportunity were mobile geologists, Curiosity is that as well, but also has a whole series of onboard chemistry labs. And so there's a couple instruments inside the rover that are really special that we use to analyze drilled rock powders and tell us a lot about the very specific compositions of the rocks and what their history may have been like, and whether they had the potential to have all of the ingredients that we know life needs to survive. And I do have to point out, because I know a bunch of you are calling in from Canada, that one of the really important instruments on the rover's arm, called the Alpha Particle X-ray Spectrometer, or we like to call it the APXS, that is an instrument that was built and is operated from Canada. So there is a great group from Canada that is exploring along with us on this wonderful, wonderful rover. Now, Curiosity landed in a site called Gale Crater, which is this big impact crater on the surface of Mars. It's about 150 kilometers in diameter, really big. It formed about 3.5 billion years ago when a giant rock slammed into the surface of the planet and created this crater. But what we're really interested in this crater is not because of the crater, but because in its middle, there is a mountain, which we've named Mount Sharp. And what's extraordinary is from orbit, we can see that Mount Sharp is actually a layered mountain. And we can see that the different layers in the mountain have different compositions, have different textures. And so we think what this is, it's a geological record of Mars's history. And each rock layer was built at a different period of time in the planet's history. So by landing at the base of this mountain, what we'd be able to do with Curiosity was drive our way up through the rocks, kind of like chapters in a book, reading the oldest chapter at the bottom first, and then moving younger and younger to learn more about the history of Mars. And the question that we're trying to answer with Curiosity is whether Mars not only had liquid water, but whether it had all the ingredients life needed, things like carbon-containing molecules and sources of energy. This was the view when Curiosity landed. We couldn't land on the mountain itself because it was too steep. So instead, we landed on these really flat plains on the crater floor next to the mountain. But you can see it's this beautiful mountain looming in the distance. And as soon as we landed, we were so excited to drive there. But even before we got to the mountain, we started to find some really interesting rocks that told us about the history of this area. This is what some of the rocks look like right at the rover's wheels when we landed. And what is significant about this rock is it's something that geologists call a conglomerate, which is a fancy word to basically say it's a rock that's made of a bunch of other rocks. And what's really interesting here is that you can see these other rocks that are all kind of smushed together to make up this rock. There are these pebbles that you can see in here. And what we can see is the pebbles are very rounded and they're pretty big. And so because they're rounded, we know they were transported a really long way. And because they're really big, we know the system that transported them was probably pretty energetic. And so what we think this is actually really similar to river rocks that we find on Earth, where we have rivers carrying these big pebbles along the bottoms of its stream. And so this told us right away that we'd landed in an ancient riverbed. Looking off into Mount Sharp, we could see all of these layers and layers and layers, just like we thought we'd see from Earth. And then we actually got up close to the base of Mount Sharp and we looked at the rocks forming the bottom of the mountain. What we saw were even more layers. So this is an uncountable number of layers of rocks that are really, 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 really fine grained is the word we use. If you look at it, even with your most magnifying hand lens, you can't see the grains that make up this rock. And these layers are relatively flat lying and parallel to each other. And on Earth, this kind of rock will form in an environment where you have very calm water, you have very, very small particles settling out very slowly over time. And so putting this all together, we found a picture of Gale Crater that probably sometime in the past, it looked something like this, where we had rivers coming into the crater floor and then filling a big lake that built up the bottom of the crater. And what was extraordinary was as high, we climbed higher and higher and higher on the mountain. And for years, all we saw were rocks that looked like they were deposited in lakes. And so this told us that not only was there a lake that once filled this crater, this lake had probably been around for millions and more likely tens of millions of years. So not only was Mars once a much wetter place, but it had water that lasted a really long time on the planet's surface. Here's a picture of where we're exploring now, and I'll go ahead and click through it, and it's just turned into this beautiful area. What we found is we eventually, after many years, we found that the rocks started to change, and they started to look more like rocks that were deposited in mostly dry, although occasionally wet environments. And so that's where we're exploring now. We found this period of time where Mars's climate changed, and the rover, we're way up kind of in here at this point, driving up this really rocky channel. But here's another picture that I love to show that Curiosity collected. These are pictures of all of our drilled samples. So I showed that drill that was on the end of Curiosity's arm. We make that rock powder, and then we put it inside our onboard laboratories on the rover. And what we found was that the other ingredients we were looking for life, carbon-containing molecules and sources of energy, those are present on Mars too. So that was very exciting. But what I also just love about this picture is that you can see all of the different colors. So usually we talk about Mars as the red planet, but it turns out when you get below the surface, Mars is also the gray planet and the purple planet and the red planet and the brown planet. And all of those different colors tell you something about Mars's changing composition and the changing environments it experienced through time. Right now, Curiosity is actually pretty high on Mount Sharp, and we've spent the last few months investigating this really cool feature that cuts through all of those rock layers. This is an orbital perspective. The rover's about where this blue star is. But what you can see is this really, it looks like this sinuous channel coming down. As scientists, we thought it was interesting because we wondered if maybe this was a very late river that maybe came and cut through the whole area. So we wanted to study it. And what we found is the rocks in here, we haven't found any obvious evidence of a river yet, but maybe this channel was carved by a river and then it was later filled by rocks that came down through avalanching, or we call it debris flows, when you have slurries of rock and mud. But the really cool thing was when we drove into this channel, we saw something like this. And what we saw for the first time ever were these kind of white looking rocks. That was weird and really unexpected. And so, of course, we said, we got to go check those out. So we drove the rover up to them. This is what those white rocks look like, really bizarre looking rocks. I've never seen any Martian rock that looks like this. And I've been looking at Martian pictures for 20 years. So we did was the wheel, we drove over one of the rocks, we were able to crush it open, and inside you can see it looks a little bit yellowish. And actually, when we put the instruments down, and especially that Canadian built instrument that I mentioned on the arm, it told us this composition of this rock was pure sulfur, which is an element we see in minerals, lots of minerals on Mars, but here it was in its pure form. On Earth, you can get pure sulfur that forms in places like volcanic environments, but we don't think we're driving up a big volcano. So we're really puzzled how this formed and how this got there. We've never found pure sulfur before on Mars. And we're still trying to figure it out. But this to me highlights why exploring Mars is so interesting. Even though we've been on the surface for a really long time, we're still finding really new and perplexing things that are so fun to study and explore. And it was so fun to see this data come down for the first time and just go, what? What is that? What does that mean? It's one of the best parts of being a scientist. But I'll go ahead and wrap up and talk a little bit about other things that I'm working on, thinking of the future. And this is a picture of the next Mars rover we sent called Perseverance. But what I really want you to take a look at is in the background here, Perseverance brought a little buddy with it named Ingenuity. And what Ingenuity was a tech demonstration of a helicopter that could fly on Mars. And here's a little video we can see of Ingenuity just landing. Ingenuity worked amazing. It was only supposed to go for 5 flights and it went for something like 72. And as a scientist, I'm so excited about this because I can start to think about, well, if we can explore Mars with rovers, can we explore Mars with helicopters? And so this is something I've been thinking a lot about. This past summer, I got to go out to Southeast Oregon to study some sites that looked very Mars-like. You can see there I am just off in the distance. We were looking at an area that had just a little bit of water coming out onto this very mostly dry, clay-rich area. You can see these hills in the background. These are lava flows. They look very Martian. And we were able to go out and actually practice flying around some of our own drones on Earth. Let me get out of my PowerPoint. Here we go. Our own drones on Earth and use them as tools to understand what it might be like to use drones like these on Mars to explore the rocks on Mars, to take to the sky, and to think about how we would see the planet differently from really high up, and we can fly really, really far distances on Mars. So this was a really fun way to spend the summer doing all sorts of cool science. Now, you might remember I told you Mars's atmosphere was very, very thin. So a drone like this, we couldn't send it to Mars. It wouldn't fly. So instead, we've been working really hard at JPL thinking about how could you fly a drone on Mars? And this is the design we're currently looking at. It's a giant helicopter that I'm very excited about because it's much bigger than Ingenuity. We can put a lot more science instruments on it than Ingenuity. And I'll just end with my dream of where we could take a helicopter like this. Mars is home to the biggest canyon in the entire solar system. It's called Valles Marineris. It's way deeper than the Grand Canyon. It would stretch the length of the United States from California to New York. And I would just love to send a helicopter into the canyon and explore the ancient rocks that are exposed there and learn even more about Mars. So thinking towards the future, maybe that's some mission we'll be able to do one day. But in the meantime, I'll go ahead and wrap up. And thank you so much for your attention and invite you to explore with us anytime. You can visit mars.nasa.gov to learn more about Curiosity and the other missions that we are using today to explore the red planet. So thank you very much.
Thank you very much. That was awesome as always, and some cool new footage of drones in action. I love the note that our regular drone wouldn't fly on Mars. We're going to come back to that, I'm sure, in the Q&A, or I'll make sure we do anyway. But before we dive in with questions, we're going to do our Kahoot together. So see who's paying attention, have some fun, test some understanding. If you want to bring up that game pen, please do. And Abby, as you may remember from the last time we did a Kahoot together, if you want to give us little hints when there's like 5 seconds to go, you are welcome to. But for those who are new to Kahoot, the faster you answer, the more points you get. And what you win is Abby and I's everlasting respect. So that is pretty cool. And if you just want to yell out the answers in your class, that's totally fine as well. But feel free to pull up that game pen and we are going to get underway. And then our cacti crew are going to be our first class for questions. YouTubers, you guys can chime in as well. So let's get started. You can start after we've begun and we'll see what happens with our questions here. All right. That was so much fun. I love our broadcast together. Honestly, it's one of the great joys of my year.
Aww.
All right. How big compared to Earth? You said something a little different than I have as our answers here, but is it about half as big? Is it exactly the same size? Is it twice as big? Or is it 1/4 the size? What do we think? And if you want to give us a little hint with this one, we'll take it. Get those answers in. Oh, we've tripped up everybody. No one's
definitely smaller.
Definitely smaller. It is about half as big. So for those who are nervous to throw in an answer there, it is half the size, roughly. So you said about 1/3 the size of the Earth?
Yeah, order of magnitude.
Order of magnitude. How many rovers have successfully been to study Mars? And if you want to spell the answers out, is it 1? Is it 5? Is it 20? Or have we sent like 100 rovers to Mars in our time?
Well, I wish it was 100.
Yeah.
I should know more than one because I've said more than one.
You have, and everyone got that right. It is 5 rovers to date. We've got a few landers. We've got the helicopter. We've got these fun tools. But in terms of driving around, 5 so far, with more to hopefully come in the future en route to us getting there ourselves. All right. Question 3 or 4. True or false? Mars used to have flowing water on its surface. I hope we all get this right. This is one of the central ideas of the whole broadcast. This picture, by the way, is of like right down the road from me. Kind of looks like what Mars could have looked like. We got the tablelands in Newfoundland. They're very odd.
That's
Peculiar.
beautiful.
It
I would
is.
love to go there.
Come on over. Bring the drone. We'll have some fun. It'll be perfect. All right. 9 answers in. The answer is, of course, true. Yes, you all got that right. We're going to skip our leaderboard to go to question 4 because question 4 does not have a right answer. It's literally just what we think. It's like an optimism, pessimism check. We will one day walk on Mars. What do we think? Are we going to go to Mars? Are you guys going to go to Mars? Or no, we're never going to make it? What are our thoughts?
That's a good picture.
I think so. All right, 8 answers in. 7 more seconds. Let's see what we think. Yes or no? I will say that pretty much every scientist is on one side of this debate. And that is that, yes, we certainly will. We're pretty close. We're going to be going to the moon in the next couple of years, which is really exciting. It's like the golden age of space exploration right now. So if you're an optimist, now is your time to be interested in all these kinds of broadcasts. Speedy Eagle's third, Knowing Shark is second, and first for all the marbles, as we head to our cacti crew in a sec, is Fuzzy Raccoon. If you are any of these folks, let us know who you are. But thanks for playing no matter what. And we're going to head to Churchill. Hello, Alternative Public School. Unmute your mic. Come on in. Share a question. Hello, folks. Hi.
Hello. How are you?
We're great. How are you?
We are great. Thank you. Question. Who's got one for Dr. Abigail? Audrey, go for it. Big loud voice, honey. That was the question. Do you have a question?
Have you ever recorded any videos on Mars?
So the question is, have you ever recorded any videos on Mars?
Nice.
Excellent question. And the exciting answer to that is yes. So both Curiosity and Perseverance, which is the newer rover, have the ability to record videos. We don't do it very often because they take up a lot of space. And when you're trying to send data from Earth to Mars, it's very, very slow. It's like if your internet really slowed down. So we try to just send back pictures. But sometimes when it's important, we do take videos like what I showed of the helicopter landing. That was a video.
So cool. I love that we even have that capacity. And that, again, if you guys go to mars.nasa.gov, like you can look up the most recent pictures and videos and stories from Mars, which is wild that we have things on another world that you can just check out willy-nilly anytime you want. So I love that as our first question. Thanks, guys. Mr. Barr's class, we're going to head to you guys next. If you want to unmute, come on in and take us away in Wilson Avenue.
Hello. All right, I have a question from Hassan here.
Hey, Hassan.
How long does it take to get to Mars?
Yes, great question.
Yeah. How long does it take to get to Mars? Well, Mars is pretty far away. So we launch things on a really big rocket, and usually it takes about 6 to 9 months to get all the way there, depending on how we plan the orbit.
I want to put this in contrast as you talked about Europa Clipper at the beginning of the broadcast too. So the moon is like 2 to 3 days away. Mars is like 6 to 9 months. And then Europa Clipper, Jupiter, is like 6 years it's going to take to get there. So the solar system is huge. Mars is our closest planetary neighbor, and it's still 6 to 9 months. And we can only do that at certain times when they're pretty close together. So I love when we get this question. Thanks, Hassan. All right. Ken Danby Public School, Miss Evanbergen's class, come on in and take us away. Hey.
Hi, we have a question from Grace.
What's the most common material that you found on Mars?
Ooh.
Oh, good question. I think the most common material we find are these lava rocks. We call them basalts. They're made of iron and magnesium and silicon and oxygen. And most of the rocks that we find on Mars are basalt with some degree of evidence of interaction with water. When you add water to basalt, you can make things like clays. But that's the most common rock we find.
Yeah, great question. Thanks, guys. We did a fantastic first round together. We're going to take some of our online crew for a minute, then we're going to come back to all three of you for live ones. So Miss Fox's class, they're just joining in on YouTube. They're in Arlington, Massachusetts, and they have a bunch of students that want to know what it's like working for NASA. What does it take to work for NASA? What does it feel like? Share a little bit about your career story for a sec.
Yeah. Oh, well, it's really fun. It's my dream job. It's something that I wanted to do ever since I was little. And what I really love about working for NASA is the people that I get to work with. So we're doing interesting work, but I get to do this work with some of the smartest, most passionate people on this entire planet. They all love what they do. And what's also really cool is that all of us have slightly different backgrounds. So my background, I studied physics and geology in college. I am a geologist. But I get to work with engineers, aerospace engineers, mechanical engineers, electrical engineers. I get to work with communicators, people whose job it is to help us tell our story of the kind of science that we find. I get to work with people who have studied business, who help us manage the finances for these really complex, difficult projects. And I just love working with this group of people who have diversity of backgrounds, but who are all so excited about what we get to do, which is explore space and answer these really big questions.
What a beautiful answer. Thanks, Abby. We've done a bevy with Abby in the past. And again, if you want to see programs that she talks like the full swath of her career journey, it also features In Goodnight Oppie with that amazing Prime documentary. I really encourage you to check out her broadcast. It's one of the best career stories ever in the history of exploring by the seat of your pants. And it's really, really exciting. I want to harp on this. Why would a drone that I can fly around here in Newfoundland not work on Mars? Do tell before we go back to the cacti crew.
Yeah. So on Mars, the atmosphere is really, 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 really thin. And so imagine trying to go to, say, the top of Mount Everest and trying to find a helicopter. It's really hard because there's just not a lot of atmosphere for the blades to grab onto. So they've done several things to get helicopters to fly on Mars in this really thin atmosphere. The first is work really hard to make these drones really, 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 really light. So come up with all sorts of fancy carbon composite-like materials to get really strong, but really light materials. They also spin the blades really, 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 really fast to give the helicopter enough lift to be able to take off. And something we're thinking about for this next helicopter that we're doing for the first time is actually making, a lot of blades and making pretty thick blades. So blades that look more like what you might get on a submarine rather than a helicopter here on Earth, and see how that works. But it's a really challenging problem. And I'm just blown away by the engineers who are able to solve this. I'm not the aerodynamics person solving this. I just get to be the scientist who dreams about how to use it.
It is certainly super, super cool. And as you were saying this, I'm reminded, you correct me if I'm wrong, the moon has no atmosphere. So could we fly drones there at all? Like, would we have to come up with totally different engineering? Is that even a conceivable possibility? Like, there's nothing on the moon. So...
That's actually a great question. And we've been talking about whether we can use some of the things we've learned from the Mars helicopter on the moon. But you're right, there's no atmosphere on the moon, so you wouldn't be spinning blades. But yeah, maybe if you put some little puffers of gas on them, you could have what we're calling a hopper. And you could still kind of hop up and travel from place to place. But we would use the same kind of processing techniques we're using on Mars for this autonomous flight, finding on your own safe landing places. We could apply that to a hopper on the moon.
Okay. Thank you very much for humoring me. That was fantastic. We're going to do another round of questions. 5 more minutes, 3 more questions. Cacti crew, come on back in at Churchill Avenue, and you guys are good. Hey, guys.
Hey, Charlie, go for it.
How fast is like the rover move like on Mars? How
Great question.
Yeah, so it turns out the rover moves really, really slowly. You would see it move, but it just a couple centimeters per minute. And the reason the rover moves so slowly is because it has a computer that's doing a lot of processing to make sure where it's driving is safe. And it's a really old computer. We designed the computer like 20 years ago. And so it just takes a long time to do all of this processing. Mars is so far away that we can't command the rovers like with a joystick real time because it takes the signal 10, 15 minutes to get to Earth. So what we'd be seeing if we were trying to drive the rovers real time would be where the rovers were 10 minutes ago, which is no good. So we'll plan a drive all automatically, and then the rover has to execute it and use its own special software to make sure that what it's doing is safe. Usually in a day, we'll go about 30 to 100 meters, depending on the terrain. It's about the size of a football field.
I like to think of it this way for kids. Imagine you have a remote control car, and every time you press a button on the car, it takes 10 minutes for the car to actually do what you've done. And the car is worth many billions of dollars, and it's in an entirely new environment. And if it gets stuck, you cannot go pick it up. You're going to be very cautious with how you move that remote control car around. But it does allow us to explore big areas over a longer period of time. And that's a bit of the opportunity story as well. So cool question, guys. All right, Mr. Mars class, come on in. Miss Sevenberg, and we'll wrap up with you in a second.
All right, Kai has a question for you.
You had a picture of the rover on Mars. Can the rover take selfies or?
Yes. Cool question, Kai.
Excellent question. And the answer is yes. Just like you on Earth, we like to take selfies on Mars. There is a little hand lens that's on the end of the rover's arm. And what we can do is we can actually turn the arm around and we can do all sorts of movements with the arm and take a picture of ourselves. And you can actually look, if you see a picture of the rover on Mars that the rover took of itself, that's how we did it. We took our arm out and the camera on our arm and we took a selfie.
I love it. I've seen some pictures of it when we were practicing on Earth, showing what that would look like as well. So you can get a sense of what this looks like in some of our other broadcasts. But that is a very, very neat question. How do you get a picture of something when it's just alone on another planet surface? Very cool, guys. All right, Miss Devenberg in class, we're going to wrap up with you in a second. I do want to stress, JPL, if you want to follow the Jet Propulsion Laboratory, it's like the coolest, most storied facility in the world. Mars.nasa.gov for so much more, and our YouTube channel if you want to check out more of Abby's presentations, the rest of our space things all month long. It's been a wild ride. We really appreciate all your questions. But let's wrap up with one more. Come on back in, 6A. Hey, guys.
Do you like Mars?
Do you like Mars?
Yeah.
Yeah. Well, most of the time, I like Mars. I like studying Mars, and I think it's really interesting. Sometimes Mars makes life really hard for our robotic explorers with dust storms and really cold temperatures. And those times I don't like Mars so much. But in general, yes, I do like Mars. But it's not my favorite planet. My favorite planet is Earth. I think Earth is the most special place in the entire galaxy.
If we just hopped off to Mars, we would not survive very long right now. So the Earth's pretty great for, life and biodiversity and oceans and all that other good stuff. And I'm really glad you mentioned that, because I think the conception is that when you are working on something, it's going to be the best thing, your favorite thing. And Earth rocks. Earth beats everything, no matter what, no matter who we're talking to. So thanks for the question, guys. Abby, before we wrap up and bring in all our classes for a big thank you and farewell, is there any last message you want to leave us with about Mars and your explorations?
Just thank you so much for your time and listening. And, space exploration is for everyone in all different backgrounds. So if you're interested, no matter what, if you're an artist or a writer or a math nerd or whatever, there is a place for you in space exploration.
There's no better message than that. We've been hearing that all month long from NASA folks. And so honestly, whatever you're keen on, please, if you're interested in space, consider a career in it. There's lots of opportunities to get there. Abby, this has been so much fun. Please stick around for when we're done to say a goodbye with me too. But I'll bring in all our class to say a big thank you and farewell. Miss Sevenbergen's class, Mr. Barr's class. Thank you so much, everybody.